Assalamu alaikum dear students. Hope you are fine, you are safe, and I expect that you are utilizing this time in a productive way for your studies and other businesses. As you know that we have completed by the quadrilateral chapter. There were left some questions. I hope you can do them of your own. If anybody among you having any difficulty in that question, please let me know that I can make the video for the same. I can explain it sorry, I can explain it to you through the video lectures. So let me know that do the questions, watch the videos carefully, and take the necessary, note down the necessary information. The topic today we have selected it is the Heron's formula. It is a very simple chapter and very easy chapter and very short chapter in fact. So what is the Heron's formula? Heron's formula is nothing. It is useful as it helps us to find the area of triangle whenever we have only given the lengths of the sides of a triangle. So you know there are different formulas for the areas of triangle. In case you have a for example equilateral triangle, area of equilateral triangle is let us calculate it. If you have an equilateral triangle with sides a, then its area is equal to root 3 divided by 4 into a square, where a is the side of triangle. Again, suppose you have an isosceles right triangle, and this is a, this is a isosceles right triangle. Then in case its area will be 1 by 2 a square. How? You know that what is the formula for area of triangle? It is 1 by 2 base into corresponding altitude. If we consider this base, this altitude, a into a is a square. So area of isosceles right triangle is 1 by 2 a square. And area of any triangle is actually basic formula is 1 by 2 base into corresponding altitude. 1 by 2 base into corresponding altitude. What does this corresponding means? Corresponding means that we have selected that side, the base on which the altitude lies. So suppose we have here two altitudes. Let us suppose that AD and BM. Suppose we have two altitudes AD and BM. So how can you if we select, suppose 1 by 2, if we select BC as a base, if you already whenever you are asked that what is the area of the triangle, you usually say that it is 1 by 2 base into altitude. So if that is not correct way to express it, why? Because there are two altitudes. If you select base BC, say, then altitude are AD, altitude is a BM also. So you could write here, you can write here BM as well as AD, but that is not true. You have to select the altitude of that base on which altitude you have to select that altitude on which you have the it lies. So here if we have selected the base BC, so altitude should be 80. This is true. Suppose you could also take the base AC, so it is 1 by 2 AC. Then in this case BM, you have to take altitude as BM. So we called that altitude of a area of a triangle equals 1 by 2 base into corresponding altitude. These are the basics. Some you know it very well, and you have already learned it in your previous classes. In today's video lecture, what we are going to discuss, it is about the Heron's formula. Suppose you have only given a triangle, any triangle A, B, C with three sides, different sides A, B and C. So if we are interested in finding the area of this triangle, how can we do it? We must know we know the value of this side, this side. So we have to, first of all, we could find its area by, if we draw a altitude here. If we draw altitude, we can find its area, but the problem is here we don't know the length of, we are unable to find the length of this altitude. Suppose if we draw AM altitude here, let us suppose this is AM. So this side we know, this is C, no problem. But if we have to take the altitude AM, how can we find the length of AM? It is impossible here to find the length of AM. Very impossible. One way we could have find it, if this is an equilateral triangle, then easily we can make them congruent, we can find the length of AM. But this is a scalene triangle, a triangle with no sides equal. So in this case we will use the concept of the Heron's formula. Heron's formula, actually it is the name after the mathematician Herons. So what does this Heron's formula state is that if you have a triangle having sides A, B and C, then it is area equals root of S into S minus A, S minus B into S minus C. What is this S? S is the semi-perimeter of triangle. One is perimeter. So let us have a look. Perimeter of triangle is A plus B plus C. Is it? Sum of sides of a triangle. The boundary, we called it a perimeter. You are already familiar with it. So what is the semi-perimeter? Semi-perimeter is half. So if you have to find the half of any quantity, so how can you find the half of any quantity? Just you divide it by 2. So we will write S equals A plus B plus C divided by 2. That is it. So S equals A plus B plus C divided by 2. So this S equals sum of sides divided by 2. This is semi. A is any side. It is not necessary that you will take first A, first B, because multiplication is commutative. You could take any of the sides, root of S into S minus A, S minus B, S minus C. So this is the formula. This is the formula given by the Herons, that area of a triangle you can find it with the help of this formula, root of S into S minus A, S minus B into S minus C. So let us take an example and try to find the area of any triangle with this formula. Suppose we have a triangle having sides 5, 6 and say 9. 5, 6 and 9. So these are the lengths of the sides of triangle. First of all, we will find S. S equals 5 plus 6 plus 9 divided by 2. Sum of sides of triangle divided by 2. It will come out 20 by 2, that is 10 centimeter. So semi-perimeter is 10 centimeter. So let us use the formula. Area equals root of S into S minus A into S minus B into S minus C. A, B, C is any side. You can consider this A or this B, this C, this A, this B. You have nothing to do it, but just you have to take S minus A one side, S minus B another side, S minus C another side. So it is 10 into 10 minus 6. Let us take this A, 10 minus B, or this, whatever you may feel convenient. S minus B, 10 minus 9 into S minus C, 10 minus 5. So it is root of 10 into 10 minus 6 is 4, 10 minus 9 is 1 into 10 minus 5 is 5. So it is 10 into 4, this is 4 here, 10 into 4 into 5. It is 4 into 10, 40, 40 into 5, root of 200. So square root of 200, it is, no, you can keep it as it is, because it is not a perfect square. So in this way you can find the area of any triangle by using this Heron's formula. So this is the basic idea about the Heron's formula. In the next video lecture, inshallah, we will do some textual questions and try to finish it as quickly as possible, because this is a very easy chapter. You can do it maximum questions of your own, and after finishing this we will move towards the circles. This chapter is also meant for your U3 examinations, so it will take us 2 to 3 days to complete it. Thank you, class.